In this problem, we are giving some information and we need to figure out what is compound A, B, C, and D. So, oh, I didn't put a D here, so this is D. I need to find this out. What's C, what's A, what's B, what's D, and the information that I'm giving is the structure of the compound here. The results of C reacting with dimethylamine. And here you have this compound. This compound is an enamine. And when you hydrolyze enamine, you go back to a carbonyl compound and to a secondary amine. So this tells me what is a carbonyl compound. So the carbonyl compound must have the following structure. This is, oh, I think I'm missing one carbon here, isn't it? Yeah, I'm missing one carbon. That's the information I was giving. So that is the ketone. So you're hydrolyzing the enamine, you get back the carbonyl compound and the dimethylamine. So that's the structure of C we got right there. Now we can complete the rest of the puzzle. So let's say here I need to figure out what is the reagent to, I have benzene and I need to make it this. So what am I doing? I'm adding this group. So I'm doing a Friedel-Crafts acylation. So I need to install all of that, this, 1, 2, 3, and I need to have a chlorine. So it's with an acid chloride. So the structure of B needs to be this acid chloride. Again, you're doing Friedel-Crafts. And aluminum trichloride is simply a Lewis acid catalyst. Okay. Right now we have C and B. Let's go over here. What is this? This is a Grignard, so I'm going to write it like so. And now this is my nucleophile, and it's going to attack here. So let's do, this is going to be a big arrow because I need to go around and attack here in C. So from the nucleophile to the electrophile. So initially I will form, after the Grignard attack, I'm going to have O negative here. I'm going to have my ethyl, and I'm going to have another ethyl group. I had attack here, 2 carbons, 2 carbons. And after protonation, the structure of D will be the following alcohol. So you're going to have OH, ethyl, ethyl. That is a tertiary alcohol. Okay, so we got everything but A. So I need to go back to A. That is an ozonolysis reaction. If I'm only given that this by ozonolysis gives one product, I need to draw an alkene that is symmetrical so that when I break it, I get this. So I'm going to draw this again, but let's do this. This is that. So I'm going to get this from an alkene, and that alkene need to have the same so that I get the same product. It could be this, so that when you do ozonolysis, you get 2 moles of the ketone. And you can have, this is actually the Z isomer, or you can have the other stereoisomer, which is, this is phenyl, and here I will have that 2 phenyl opposite side, and the 2 ethyl. So this is the E. Either of these two alkenes will give you, by autonolysis, this. So the only information that I got is this gives this. So I'm assuming that it's a symmetrical alkene. If you were given something else, so for example, that you get C plus, say, formaldehyde, then you will need to think of a different alkene. Here you can have simply this. This alkene, when you do ozonolysis, the oxidative cleavage would produce the same ketone, but now 1 mole and 1 mole of benzaldehyde. So it depends. But the problem here, what it had is just this structure. So I'm assuming that it's symmetrical, so it has to be phenylethyl in the alkene on each of the vinyl carbon. And you can count from the C or the E diastereomers. Either way.